Hello guys, welcome to IB Math Solution. Today we will start a topic straight lines. First, we'll discuss the basics of straight line and linear equations. Then we'll practice some questions from exercise 1A covering the concepts we'll study in today's lecture. So without any further delay, let's start. So when we say line, what do we mean by a line? Suppose we have this x-axis and this is y-axis. This is zero origin. What do we mean by a line? When we say a line, it can be any straight line like this. It can be any other straight line like this. It can be any other straight line like this. These all are lines, and each line in this xy plane has an equation in the form of ax plus by is equal to d. This is a form of equation. We'll come to that, but in the beginning I'm going to talk about the gradient of line. What is a gradient? Suppose we have a line like this, and we take 2 points on it. These are 2 points. Let's call this point 1 P1 and call it point 2 P2. And this line is also in an xy plane. This is x-axis, this is y-axis. Now can we say this point P2 cuts somewhere on this x-axis? Let's call this point x2. Similarly, this point P1 also cuts on somewhere on x-axis. Let's call it point x1. The same points also cut on the y-axis. P1 cuts on y-axis, let's call it y1. P2 cuts on y-axis, let's call it y2. Now can we say that this P1 has coordinates of x1 and y1? Similarly, this P2 has coordinates of x2, y2. These two are the coordinates of the points we have selected. Now let's say if we extend this straight line, this will cut P2 x2 somewhere over here, and this will make a right angle triangle. This will be exactly 90 degrees. So can we say this is a triangle, right angle triangle? Now when we talk about gradient is always equal to y2 minus y1 divided by x2 minus x1, and we denote this gradient by m. This is what we mean by gradient. For every step increase in x direction, what is the increase in y direction? We also write it in this form, delta y divided by delta x, where delta y is equal to y2 minus y1 and delta x is equal to x2 minus x1. Now this was our first property of line. Now the second property of line is y-intercept. Y-intercept means where the line cuts the y-axis, meaning there is some value of y at x is equal to 0. Also, there is this third property, which is x-intercept. This means where the line cuts the x-axis, or we can say some value of x at y is equal to 0. Now, for example, if we take the example of this, and we have this line, can we say this is 0? Can we say 1 would be somewhere over here, then 2, then 3, and so on? Can we say that minus 1 would be somewhere over here, then minus 2, then minus 3, and here minus 4? Similarly, if we take y-axis, can we say 1 would be somewhere over here, then 2, then 3, then 4, and so on? Now what do we mean by x-intercept and y-intercept is this x-intercept is where this line cuts the x-axis here at this point. So in this case, x-intercept is -4. Similarly, y-intercept is where this line cuts the y-axis here at this point. We can say y-intercept is 4. Now, keeping this into the mind, we can also find the very first property we have just shown, gradient. What would be the gradient over here? Can we say this point is 0, 4? Here x value is 0 and y value is 4, and this point is -4, 0. Here x value is -4 and y value is 0. So what would be the gradient over here? M is equal to y2 minus y1 divided by x2 minus x1. Can we say, considering this point as P2 and this point as P1, can we say y here is 4 and y here is 0? Similarly, x here is 0 and x here is -4. Solving this equation, we get 4 divided by 4, which is 1. So our gradient is 1 here. So these three collectively are called the properties of line. These three collectively are called properties of line. Now, when we say a line, we can also have its perpendicular line. So for example, let's consider another example. Suppose we have this x and y axis, and we have a line here. This line can be any line. There can always be another line that is completely 90 degree to this line. We can call this line perpendicular to this line. Now, when we say a line is perpendicular to some line, in that case, suppose the gradient of this line, this red line, is m, then the gradient of this blue line, now the gradient of this blue line will always be -1 divided by m. This topic is gradient of perpendicular line. Now by perpendicular, we mean a line at 90 degrees. So our initial line was this red line, and this perpendicular is 90 degree to this initial line. That's why we're calling it a perpendicular line, and the gradient of this perpendicular line is -1 divided by m, where m is the gradient of the original line. Coming to the third part, equations of a line can be written in 3 forms. So one form comes from this part. When we say gradient is equal to y2 minus y1 divided by x2 minus x1. Suppose rather than writing like this, we write this equation as y minus y1 divided by x minus x1. So rather than calling a point y2, I'm calling that point simply y, and rather than calling a point x2, I'm calling that point x, simply x. Can we write the same equation as m into x minus x1 is equal to y minus y1? So this form of the equation, linear equation, is called point gradient form, and we can rewrite it in the form where x1 and y1 can take any integer or any number value. Coming to the second type, we can write a line equation as, it is called gradient-intercept form. So first was point gradient form, second is gradient intercept form. Now, how do we write this gradient intercept form of equation? This is written in the form of y is equal to mx plus c. This is gradient intercept form. And there is third type of linear equation, which is general form. Now this general form is ax plus by is equal to d. This is the general form of equation. Now this is it with the concept part. Now we'll move on to exercise 1a and we'll solve some questions. So starting with our exercise 1a, this is our question 1 that says state the gradient and y-intercept of the line with equations. Now there are 9 equations. For each and every equation we have to give the gradient and y-intercept of the equation. So I'll be solving 1i. Solution. So when we say y is equal to 3 minus 5x divided by 8, now we have to find two things. First, gradient, and second, y-intercept. Can we write the same equation in the form y is equal to 3 by 8 minus 5 by 8x? Now you can see this form of the equation matches other questions in the same question number 1, such as this, and not to mention the one we started with. This form matches with this and this. So we are already covering with these two equations, we are already covering 1, 2, 3, 4, and 5 questions out of these. And not just 5, all of them, because instead of 3 here, instead of 11 here, we have 3 by 8 and we have 5 by 8. So writing this equation in the form, the gradient intercept form, when we write this equation in gradient intercept form, what was the gradient intercept form? Let me write it again. Gradient intercept form is y is equal to mx plus c. Can we say the same equation can be written y is equal to, now I'm writing this x term, I'm writing this x term first. So when I'm writing this x term first, can I say I'll be writing it like this, and I'm writing this other term, it has a positive in front, so I'll be writing plus 3 by 8. Now comparing this equation with this, we know that this is gradient, and we also know that this is y-intercept. So now our equation becomes fairly easy. The term here minus 5 by 8 is our gradient, and the term here is our y-intercept. By 8, and this is our answer. Now just as I solved this question 1i, any other question can be solved the same way. We'll move on to question number 2. Find in gradient intercept form the equation of the line which has gradient 3 and passes through 4, 1. Now when we say gradient intercept form, now I'll be solving only one out of the 6 given here. Let's say I'll be solving this one. So others you can solve yourself. Now gradient as seen in gradient m is equal to minus 3 by 4, and y-intercept is 4. Can we say the equation would look like y is equal to minus 3 by 4 x plus 4? This is our answer. Now I see there are two forms of questions, so I will also be solving this one. Now here gradient is equal to minus 2 by 3 and passes through minus 2 comma minus 7. Now here this is not y-intercept. this is not x or y intercept. What this is telling us is, let's suppose we have x and y, and we have a point -2, -7. So -2 would be somewhere around here, -2, and -7 would be somewhere around here, -7. Now where these two points, where these two lines intersect, this is our point. Now the question says our line passes from this point. Our line that has gradient of -2/3. Now another thing that I want to tell you guys is, when we have a positive gradient, it means the line would look like this. As we increase in x direction, we also increase in y direction. This means positive gradient. But when we have negative gradient, it means as we proceed in x direction, as we increase in x direction, we decrease in y direction, or vice versa. This means we have negative gradient. So when we say we have a gradient of -2/3, do we mean our line will look like this, or our line will look like this? We surely know a negative 2/3 gradient line would look something like this. So if we draw a line of -2/3, this will be our line. It has to pass through this point, and this will be our line. Here our point gradient form will come in handy while getting an equation for this line. So what was a point gradient form? Point gradient form says, when we have m is equal to y minus y1 divided by x minus x1. We know what our m is. M is equal to -2/3, that is equal to y minus x minus. Now this y1 is -7, and this x1 is -2. This point, this line is passing through this point, so we can give any point on this line. So in order to find the equation of this line, this will become minus minus plus, this will also become minus minus plus, and we cross multiply. -2 into x plus 2 is equal to 3 into y plus 7. When we multiply further, this becomes -2x minus 4, 3y plus 21. Now keeping y on one side and taking everything on the other, -2x minus 4 minus 21. Can we say y is equal to, 3y is equal to -2x. Now this whole thing becomes -25, and y is equal to -2x minus 25 divided by 3. Now dividing it further, now can we say this equation is in this form, mx plus c? When we say this equation is in this form, then we mean that m is equal to -2/3, which was already given, but y-intercept is -25/3. And in this question, find in gradient intercept form the equation of the line. So this was the extra step we did, but in gradient intercept form, this is our answer. This is our final answer. This is the form of gradient intercept form, and we got the equation for this line in this form. Moving on to question number 3, consider the table of values alongside. Now we have some values of x, 0, 1, 2, 3, and 4, and the corresponding values of y for those values of x. That is 5, 8, 11, 14, 17. Now the question is asking us to draw a graph of y against x. Now y against x is, now suppose let's mark numbers on this. This is our x-axis, this is our y-axis. So this is 4, 8, 12, 16 and 20. This is 1, 2, 3, 4, 5. Now it says for 0, for x is equal to 0, we have y is equal to 5. For x is equal to 0, we have y is equal to 5. So this point will be somewhere around here, 5, 0, 5. For x is equal to 1, y is equal to 8. For x is equal to 1, y is equal to 8. For x is equal to 2, y is equal to 11. For x is equal to 3, y is equal to 14. For x is equal to 4, y is equal to 17. If we join all these points, we get a straight line. And this is our line. So the very first part of this question we have done. Draw a graph of y against x. So this is the graph of y against x. Are the variables linearly related? Explain your answer. By looking at the graph, we can say yes, the variables are linearly related. But what if you have made a mistake in drawing this graph? If you have taken the scale very carefully, then there would be no mistakes. But as I have not taken scales properly into consideration, I might have made mistakes. So what is the procedure to find out whether the line is actually a line or not a curve and not a curve? This can very well be defined using the same table we have used to make the graph. So as we see, when we go from 0 to 1, how much are we increasing or decreasing? We are increasing 1. We are increasing 1. We are increasing 1. We are increasing 1. While going in the direction of y, how much are we increasing in every step? 5 plus 3. We increased 3 plus 3. Again plus 3. Again plus 3. So for every plus 1, we increased by 3. For every increase of 1 unit in x direction, we increased 3 units in y direction. Had we increased somewhere over here, had we increased this x unit by 2 rather than 1, then this must have been increased by 6 for the line to be a line and not a curve. So by this way, we can say that yes, variables are linearly related. Because for every 1 unit change in x direction, there is, for every plus 1 unit change in x direction, there is plus 3 units change in y direction. And this holds true for each point given in the table. That's why we can say that the variables are linearly related. So we have done this, Now moving on to find the gradient and y-intercept of the graph. Now for gradient, we can say m is equal to y2 minus y1 divided by x2 minus x1. Now from the table, you can take any 2 points. You can take this point and this point, or you can take this point and this point, or you can take any other combination of points. So suppose we take 1, 8, 1, 8 and 4, 17. So y2 will be 17 minus 8. X will be 4 minus 1. And that is 9 divided by 3. So our gradient is 3. We have also done this. Find the equation connecting x and y. Now again, we say m is equal to y minus y1, x minus x1. We have found out that m is equal to 3, y minus x minus. Now taking any point from the table, let's take 2 and 11. 2 is x, 11 is y. Now we can find the equation. 3 into x minus 2 is equal to y minus 11. 3x minus 6 is equal to y minus 11. Taking y on one side and all other things on the other, we get 3x minus 6 plus 11, which gives us y is equal to 3x plus 5. And this is our answer. We have also done this part. Find the equation connecting x and y. Find the value of y when x is equal to 10. Now, had this x is equal to 10 being given in this table, we would have taken the y value, the corresponding y value of that x, and given the answer. But as we can see, we do not have 10 in this table for x. So we need to calculate it using this equation. We have just calculated. We have just found out the equation. Find the value of y when x is equal to 10. So this is our equation. When we put the value of x is equal to 10, we get the value 30 plus 5, which is 35. And this is our answer. Now question number 4 says, calculate the gradient of the illustrated road. Write your answer as percentage. So what is gradient? Gradient, we have said m is equal to y2 minus y1 divided by x2 minus x1. Now y2 minus y1, we have already been given with this value 104, and x2 minus x1, that is 1320. Now the question is asking this answer as percentage. If we calculate this, let me get the calculator. The answer comes out to be 0.0788. Now converting it into percentage form, we just need to multiply m with 100 and we'll get our answer. So m into 100 would be 0.0788 into 100. That will be 7.88%, and this is our answer. Moving on to question number 5. At 0 minute, we have 10 liters water here and 5 liters water here. After the end of 1 minute, we have 20 liters water here and 20 liters water here. At the end of 2 minutes, we have 30 liters water here. We have 35 liters water here. At the end of 3 minutes, we have 45 liters water here and 50 liters water here. At the end of 4 minutes, we have 60 liters water here and we have 65 liters water here. Now, the question is asking us to plot A against T for each pond. A says amount in liter, A against T for each pond. So let's draw it. Let's make axis. Let's say this is pond A, this is pond P, this is pond Q. This is amount A, this is time in minutes. Now when we have 0, the amount of water is 10. When we have 0, the amount of water, let's say, this is 10, 20, 30, 40, 50, 60, and so on. So when we have time t is equal to 0, water was here. When we have t is equal to 1, water was here. When we had t is equal to 2, water was here. When we have t is equal to 3, water was here, 45. When we have t is equal to 4, the water was here, 60. Now joining these lines, can we say these two lines, this line doesn't look like one single line. It looks like a broken line over here. Till here it is straight, but after this point it is slightly steeper. Now this will come in handy when we'll solve other parts of the question. But let's move on to pond Q. So it says, and we can also see when we are increasing time by 1, 1, 1, and 1 each time, the water was increasing by 10, 10, and then suddenly it increased by 15, and then again it increased by 15. So this pond is not linear. This will not form a linear equation. This is not linear. Pond Q, let's see, 1, 1, 1, 1, plus 15, plus 15 plus 15 plus 15. So this has to be a linear equation. 30, 40, 50, 60 and 65 would be somewhere over here. This is our t is equal to 4, 3, 2, 1, 10, 20, 30, 40, 50, 60, and this is 65. At t is equal to 0, water level is 5. I'll use another color. At t is equal to 0, water was just 5 liters. At t is equal to 1, water was 20 liters. T is equal to 2, water was 35 liters. T is equal to 3, water was 50 liters. And t is equal to 4, water was 65 liters. So we see a straight line over here. We don't see any bend in between. So this is linear. However, this was not linear. Now we have done question number 5 part A. Moving on to part B. Which pond is being filled at a constant rate? Now this is the question I was talking about when I said consider this has a breakage in between. So the speed was 10 per minute. Every increase of 1 minute was increasing water by 10 units, by 10 liters. But after this point, after 2, the water was increasing by 15. So speed was not constant over here. However, if we consider the case of pond Q, the speed has been constant all over. 15, 15, 15, 15. You can see the speed has been constant all over the time. So which pond is being filled at a constant rate? Can we say this was part A, this is part B. Pond Q is being filled at constant rate. We've also done part B. Explain your answer. Now explanation goes the same, that for increase of 1 minute, for increase of every 1 minute, the pond is being filled by 15 units, 15 liters of water in pond Q. However, it is not the case is not the same for pond P. For every minute, the pond is being filled by 10 liters of water in the first 2 minutes, and then 15 liters of water every minute after that. That's why this would be the explanation for the answer. And let's move on to part C. Part C says for the pond which is being filled at a constant rate, that means it is talking about pond Q. Now find the gradient A intercept of the line. A intercept. Now we saw the terms X-intercept, we saw the term Y-intercept. Where did this A intercept come from? A intercept is nothing but it is calling this Y axis as A here. That's why instead of Y, the question is asking A intercept. There is nothing new in this. So A intercept is where the line is cutting the A axis. A axis it is cutting wherever T axis is 0. So it can be seen from the question that T is 0, A is 5. We can say A intercept is 5 liters. It is also asking for the gradient. Find the gradient. Now gradient to m is equal to y2 minus y1, x2 minus x1. Now we can pick any 2 points from here. I'll pick, for the sake of simplicity, I'll pick the first 2 points only. So it will be 20 minus 5, 1 minus 0. That will be 15 liters per minute. This is our answer. We have, for part C, we have done subpart A. Now what these values mean, what the question is asking, A intercept is in the form of liters. When we say A intercept is 5, it has to be 5 liters, not just 5. So what these values means, A liters of water was already there before starting the hose. Similarly, when we talk about the gradient, what does this mean? This means value of A for every value of T. That means value 15 liters of water is being poured every minute. This is what the values mean. So C subpart A, subpart 1, C subpart 2. Find the equation connecting A and T. So equation connecting A and T will be We just found out m is 15. Picking any value, I'll pick 0, 5 for the sake of simplicity. When we say 15x is equal to y minus 5, taking y on one side, 15x plus 5. We have also found out the equation. Now this subpart 3 says find the amount of water in the pond after 8 minutes. So after 8 minutes, that means t is equal to 8. What will be the value of y? So y is equal to, now in this part I have done this, I have ignored this x and y. So here x means t, y means a. So when we say t is equal to 8, we in this equation we mean x is equal to 8. So calculating the values, we get 120 plus 5. This is our answer. Moving on to question number 6. An unused bank account is charged a yearly fee. The graph alongside shows the balance of the account after X years. Find the gradient and y-intercept of the line and interpret your answers. Find the equation of the line. How long will it take for the account to run out of money? What we see here is on the x-axis we have time in years. So this is first year, second year, third year, and fourth year. The amount of money was initially $90. This after first year, the remaining amount is $80. So in 1 year, suppose this is y2 and x2, and this is y1 and x1. So for sub question A, we have to find gradient. Can we say y2 minus y1, x2 minus x1? Here y2 value is 1, sorry, y2 value is 80 minus y1 value is 90. And x2 value is 1, x1 value is 0, minus 10. Can we say every year $10 are being deducted from this account, and initially it had $90. So how many years will it take for the amount to become empty? It will take exactly 9 years. This is, we can do it in our mind as well. Find the gradient and y-intercept of the line. Y-intercept we can already see. Y-intercept in this graph we can already see y-intercept is 90 dollars, and m is minus $10 per annum. So this is when the question says interpret your answer. This means initially the account had $90, and every year the amount that is being deducted from this account is $10. $10 per annum is being deducted from this account. Now find the equation of the line. Equation of the line is m is minus 10, y minus y1, x minus x1. We say minus 10x is equal to y minus 90, keeping y on one side. This is the equation of the line. Find the equation of the line. We have done this. How long will it take for the account to run out of money? Now initially it had initially, we can say initial amount is equal to y-intercept, which is $90. Now, amount being deducted, which is M, is minus $10 per annum, or we can say $10. Now, this when we say amount being deducted, we do not exactly need to put this minus sign, because we already mean that it is being deducted. We are not saying that it is slope or it is a gradient. We are already saying it is being deducted. So being deducted amount of dollars. So we can say $10 per annum is being deducted. When we have $90 initially and we are decreasing $10 every year, how many years will it take? Exactly 9. This is the answer for the question. The graph alongside shows the descent of a train down a hill. The units are meters. Calculate the gradient of the train's descent. Gradient can be calculated very easily here. See, now I want you to try questions on your own. For gradient, what do we need? For gradient, we need y2 minus y1, x2 minus x1. For this, we need 2 points. 2 points on the line. So, can we say this is point 1? Can we say this is point 2? So, this point 1 has x1 and y1. This point 2 has x2 and y2. And these x1 and y1, x2 and y2 are here. At this point, it is 18, 20, 0. And at this point, it is 0, 46. Now we have the value of x1, x2, y1, y2. We can easily calculate m. We have already done it many times. I want you to calculate this. Find the equation of the train line. We have also done this many times. You can do it. I'll move on to the next question because all the questions require same kind of computations. The height of this helicopter is, the height of the helicopter above sea level is h is equal to 150 plus 120 t. Now there is nothing different in this equation apart from the ones we have been studying. Instead of y we have h, and instead of x we have t. Everything will be done in the same manner. What height above sea level did the helicopter take off from? So when the helicopter took off, time would have been 0. T is equal to 0. Find h. Interpret the value 120 in the equation. 120 is, can we say m, or can we say gradient? So this 120 means that the helicopter is ascending 120 meters every minute. Why minute? Because it is saying after t minutes. So t is in the form of minutes. This you can do, this you can do. Now see, find the height of the helicopter above sea level after 2 minutes. Now this we have to do nothing. For t is equal to 2, we have to find h. This is the same as we did in part A. How long will it take for the helicopter to be 650 meter above sea level? Now this is a new question. I'll do it. We have equation of height, h is equal to 150 plus 120 t. Now the question is asking how long will it take the helicopter to be 650 meter above sea level. So we have the value of h, 650. If we put this value of h in this equation, what do we get? 650 is equal to 150 plus 120 t. Moving this 150 to this left side, say 4.16 minutes. After 4.16 minutes, the helicopter will be at exactly 650 meters above the starting level, above the sea level. This is our answer. Moving on to question number 9. Write in general form. Now, if we recall what the general form was ax plus by is equal to d. Now, let's take f, and every other question can be done in that fashion. Y is equal to 5 by 6x plus 3. We have to bring this equation in this form where x and y are exactly same as x and y here. A, b and d are constants. These could be numbers. So y is equal to, taking LCM on the right hand side, we get 5x plus 18 divided by 6. Now moving 6 over to the left side, 6y is equal to 5x plus 18. And if we bring this x onto the left side, we get minus 5x plus 6y is equal to 18. This equation is of the same form which we have written here. This is same as ax plus by is equal to d, where d is equal to 18, b is equal to plus 6, a is equal to minus 5. So this is our answer. And all questions can be done like this. All questions can be solved like this, right in the gradient intercept form. So now these questions have been given in the form of a general equation. Suppose let's try solving E. It says 3x minus 13y is equal to minus 4. Now which form do we have to bring it in? We are supposed to bring it into the form given by this equation. Can we say we need y on one side and everything else on the other side? Yeah. So leaving y on this side, now dividing both sides by minus 13, we get and further solving this equation, we get minus 4 divided by minus 13 plus minus 3x divided by minus 13. We can cross these minus signs out with each other, and we can write y is equal to 3 by 13x plus 4 by 13, and this is our answer. This is in the same form as this one. Y is equal to mx plus c, where c is equal to 4 by 13 and m is equal to 3 by 13. And all other questions can be solved. There is nothing new in other questions I can see. So do it on your own. I'll move on to question number 11. Question number 11 says, explain why the gradient of the line with general form ax plus by is equal to d is minus a by b. So this is a good question. Let's first write this. Let's first write the question ax plus by is equal to d. Now what we are supposed to do is just that we are supposed to bring this equation in the form y is equal to mx plus c. How can we do it? We can see y, it's just y on the left hand side of the equation. So let's manipulate the equation a bit. By is equal to d minus ax. Dividing both sides by b, y is equal to d minus ax divided by b. Further solving the equation, we get y is equal to minus a by b x plus d by b. This equation is in the form y is equal to mx plus c. Can we say by comparing these two equations that m is equal to minus a by b? By comparing these two equations, by comparing these two equations, we can say that m is equal to minus a by b, and that is why gradient is minus a by b. This is the explanation for this question. Let's move on to question number 12. Hatch pairs of lines which are parallel. So first of all, we need to know that parallel lines have same gradient. You can highlight this, it is a property, you can remember it. Parallel lines have same gradient. Now, out of these four lines, the question is asking us to tell which two lines are parallel or which three lines are parallel if there are three. Can we say A, the gradient is minus 1, B, y plus 2 is equal to 3x minus 1, y is equal to 3x minus 3, and this 2 will go over here, minus 2. So y is equal to 3 minus 3x minus 5. Can we say the gradient over here is 3? The gradient in equation A is minus 1 here. The gradient in equation B is 3 here. Equation C, can we say 3x minus y is equal to minus 2? Can we move this y over to the right side? So we will be remaining with 3x, and this 2 will come here, plus 2 will be equal to y. This y is equal to 3x plus 2. Can we say m is equal to 3? And equation D, x plus y is equal to 4. So y is equal to minus x plus 4. Can we say the value of m is minus 1 here? Now, B and C, equation B and equation C have equal gradient, that is 3. Gradient A and D have equal gradient, that is minus 1. Can we say A makes a pair with D and B makes a pair with C? Yes, that is our answer. Move on to question number 13. As we are supposed to find out which lines are parallel. So when we said parallel lines have same gradient. Now the question is asking us to find which lines are perpendicular. In order to find the perpendicular lines, suppose I taught you earlier, let's say line 1 has a gradient m, and let's say line 2 which is perpendicular to line 1 has gradient minus 1 by m. Now we are supposed to find out the gradients of each of the equation over here, as we did in the previous case, and then we need to find out the relationship of with each other, whether this relationship holds. If one is m, any other of the three equations has gradient minus 1 by m, then those two pairs are perpendicular. So let's do it. The gradient of equation A, x plus 2y is equal to 1. 2y is equal to 1 minus x. Y is equal to minus x plus 1 divided by 2 minus 1 by 2x plus 1 by 2. So gradient is minus 1 by 2. Similarly, for equation B, 2x plus y is equal to minus 3. Y is equal to minus 2x minus 3. So we can say m is equal to minus 2. Equation C, y minus 7 is equal to 2x plus 4. And we say y minus 7 is equal to 2x plus 8. Therefore, y is equal to 2x plus 8 plus 7. Or y is equal to 2x plus 15. From here we can say m is equal to 2. Equation D, y is equal to 2x minus 7. So m is equal to 2. So for this, if an equation is if a line is perpendicular to this line, then the gradient would be minus 1 divided by minus 1 by 2, which will be minus will get cancelled out and gradient will be 2. So for this line, for line A, line C and D are perpendicular because line C and D are parallel. We can also see line C and D have equal gradient, so they are parallel. They both are perpendicular to line A. So we can say A is perpendicular to C and D. This sign says perpendicular. A is perpendicular to C and D. Let's move on to question number 14. Find in general form the equation of the line which has. So let's say I'll do part C. Other parts you can do the same way I'm doing part C. Gradient m is equal to minus 5 by 3. And this is, let's say, x1. This is, let's say, y1. Then we say m is equal to y minus y1 divided by x minus x1 minus 5 by 3 is equal to y minus y1 is 6, x minus x1 is minus 2. By cross multiplying, we have to find in general form. General form looks like ax plus by is equal to d. So minus 5x, bringing 3y over to the left side will become minus 3y, and bringing this minus 10 to the other side will become plus 10. Minus 5x minus 3y is equal to minus 8. Multiplying both sides by minus 1, we'll get 5x plus 3y is equal to 8. This is our general form. Now solving question number 15. Find in gradient-intercept form the equation of the line which passes through these 2 points. Now when we have a question like this, let's say I'll do question part C. I'll do part C. You can do others yourself. We know that gradient can be written as y2 minus y1 divided by x2 minus x1. And it can also be written in the form y minus y1 divided by x minus x1. So taking these 2 forms only, this form and this form, we can find the equation. Now y2, suppose this is point 2, this is point 1. Point 2, y2 is minus 17 minus y1 is 13 divided by x2 is 1 and x1 is minus 5. we can write it in this form. Y1 is 13, x1 is minus 5. So solving this equation further, we can say this will add up to 30 minus 30. This will add up to 1 plus 6. 1 plus 5. This will remain as it is, y minus 13 and x plus 5. Now solving it further, we get minus 30 divided by 6 is equal to y minus 13 x plus 5. Now cancelling 30 out with 6, we get minus 5. Minus 5 is equal to y minus 13 divided by x plus 5. Now we can cross multiply. We get minus 5x minus 25 is equal to y plus 13. And we have to write the solution in the gradient intercept form. So gradient intercept form looks like y is equal to mx plus c. We have to write the equation in this form. So we can take y on one side and take 13 on the other. So this will become minus 5x minus 25 minus 13 minus 5x minus 25 minus 13 is minus 38. So this is our answer. We have found out the equation of the line in gradient intercept form. We can do all questions like this. There's no need to solve each and every question at my end. You can practice other 5 questions on your own and get better at it. Moving on to question number 16. Find in general form the equation of each line. So as we saw in question number 15, we had 2 points, point 1, point 2. Similarly, point 1, point 2. Now these 2 points were given us what written. Now instead of writing these 2 points in the question form, now the question has given us the graph and these 2 points have been shown in the graph itself. We can do the same. Same as question number 15. You need to practice it on your own. This is point 1, this is point 2, this is point 1, this is point 2, this is point 1, this is point 2. And you can do it on your own. I'll move on to question number 17. Find in gradient intercept form the equation of line 2. Now equation of line 2, this is line 2, this line. If I have to find the equation of line 2 in gradient intercept form, I just have 1 point given on this line, but to find the equation I need at least 2 points, or let me write this down. To find the equation for line, we must have either 1 point on the line and the gradients of the line and the gradient of the line. Both. This is one part, this is second part. We need to have these two information to find the equation of the line, or this is either, this is or we need to have 2 points on the line. See, when we have 2 points on the line, we can already find out the gradient of the line, can't we? When we can see in the previous question we had 2 points given. With using these 2 points we can find out the gradient of the line, as we did here. We had 2 points, we found out the gradient, and gradient was calculated using this equation. Then equating this value with this equation, we can find out the equation of the line. So what I'm saying is, if I need to find the equation of a line, I must have gradient of the line and at least one point on the line. If I do not have gradient of the line, then I must have 2 points on the line so that I can calculate the gradient. So let's find the solution of this question. Part A, find in gradient intercept form the equation of the line 2. Line 2 equation, we have a 1 point, that is, can we say equation of the line will be y minus 1 divided by x minus 3. Now we do not have the value of this m, but can we say this line is parallel to this line? Parallel lines, parallel lines have equal gradient. So now we know gradient for this line. The gradient for this line is 3 by 4. Can we say this m is equal to 3 by 4 as well? The gradient for this line is 3 by 4 as well. Now by equating 3 by 4 with y minus 1 divided by x minus 3, we can find out the equation of the line by cross multiplying 3 into x minus 3 is equal to 4 into y minus 1. 3x minus 9 is equal to 4y minus 4. Now keeping y on one side, so I can say 4y and I take this minus 4 onto the other. 3x minus 9 plus 4. 3x minus 5. Keeping just y on one side and taking 4 to the other. 3x minus 5 divided by 4. I can write this equation in the form y is equal to 3 by 4 x minus 5 by 4. This is the answer that we have been looking for. Now the question is also asking us find the y-intercept of the line. Can we find the y-intercept now? Yes, we can. Y-intercept is when x is 0. So y-intercept is 3 by 4, 0 minus 5 by 4, which is 5 by 4. Answer. Move to question number 18. Find the equation of the line which is parallel to this line and passes through 1, 4. Which is question part B says parallel to this line and passes through that. So part A and part B are kind of same. Perpendicular to this line and passes through that. Perpendicular to this line and passes through that. Okay. So I'll do part A. Parallel to this line means m has to be 3. Now finding the equation y minus 4 x minus 1, 3 is equal to y minus 4 x minus 1, cross multiply, we can say 3x minus 3 is equal to y minus 4. We can say y is equal to 3x minus 3 plus 4. So y is equal to 3x plus 1. So we have found the equation for the line which is parallel to y is equal to 3x minus 2, because the slope, the gradient will be same. So I took the same gradient and found out the equation. Now coming to part C, I did this, I'm doing this. These two questions you can practice on your own, and part B will be same as part A, part D will be same as part C. So perpendicular to y is equal to minus 2x. Can we say from this equation, let's call it line 1, so gradient will be m1. Can we say m1 is minus 2? And for the second line, can we say m2 will be minus 1 divided by m1, because M2 is perpendicular to M1. So M2 will be -1 divided by -2. So we got this gradient M2 is equal to half. Now the procedure after this point is same as what we followed in this part A. Same procedure. Here rather than taking 1 and 4, we'll take -1 and 5. Everything else will be same. And M2, rather than taking this 3, we'll take this half. So these three values will change. So let me write the equation. Half is equal to y minus 5 x minus -1. Now you can solve. I'll move on to the next question. I'll hurry now because we have spent too much time on this exercise. Determine whether 3 comma 11 lies on the line with equation. Yes, so I'll do part A and other parts you can do on your own because they all are same. The methodology is same. So it says 3 comma 11. Does it lie on this line? Let's check. Y is equal to 4x minus 1. Now from this equation, what is the value of y? 11. From this equation, what is the value of x? 3 minus 1. 11 is equal to 4 into 3, that is 12 minus 1. So 11 is equal to 11. Equal. They both are equal. Yes. 3 comma 11 lies on y is equal to 4x minus 1. Had these two values been not equal, then this point wouldn't have lied on this line. So our answer would have been no in that case. If this value was not equal to this value, then our answer will be no, that this point does not lie on this equation. So I have done this question. I'll write in the case this. I'll write in this case. This 11 is equal to this 11. Yes, equal. Yes. In case not equal, then you need to write this inference. No. Xy, x1, y1 does not lie on equation so and so. I'll move on to the next question. Question number 20. Find C given that 2 comma 15 lies on the line with equation. So this question here, in all these questions, part A, part B, part C, it has given us an equation, and now it is asking us to find the value of a certain constant given that there are 2 points there. So if it says that the point 2 comma 15 lies on this equation, so this 2 is x, this 15 is y. If we substitute the value of x here and y here, we get 15 is equal to 4 comma 2 plus c, and we can find c is equal to 15 minus 8, that is 7. Similarly, if we substitute the value of x and y in this equation, we can find the value of m. And similarly, if we substitute the value of x and y in this equation, so y is 4, 2 by 3 x, instead of x we need to put t, minus 4 by 3. So we can find the value of t here. Same way we have found the value of c. So do it yourself, it is very easy. I'll move on to the next question. Find k given that 0.6 comma minus 3 lies on the line with equation this. So again, same type of question. Practice yourself. We'll move on to the next question, and apparently the last question of this exercise. Find the equation of line 2. Write your answer in the form ax plus by plus d is equal to 0. Now this is another form of general equation of line. Find the x-intercept of line 2. Find the equation of line 2. Now this is line 1, this is line 2. We have to find the equation of this line. To find the equation of this line, can we say m is equal to y minus 4 divided by x minus 2. Now we do not have this m, we do not have the value of this m. This m can be calculated from the m of this equation. This m will be equal to, suppose this is m2, and if we find m1 is for line 1 and m1 is minus 2 minus 1 divided by 5 minus 2, which is minus 3 divided by 3, which is minus 1. So m2 will be equal to minus 1 divided by m1, because they are perpendicular, they are at a right angle. That's why minus 1 divided by m1, m1 is minus 1, so m2 will be 1. Now putting this value of m1, m2 here, we can find this equation. Do it, we have done it many times. And guys, keep practicing the questions. I'll come up with the next lecture for exercise 1b. Till then, goodbye.